All right, good morning students, Mr. Silber here. So we will be doing an investigation on law of conservation of mass, and we'll be doing something similar to what Lavoisier did hundreds of years ago, where he tried to discover and confirm the law of conservation of mass using a closed system. He studied a chemical change in a closed system, and he noticed that if all the conditions were right, he noticed that the mass remained unchanged before and after the reaction. So we are going to do our very best to create a closed system. It's very, very difficult. I think by the end of this, you'll realize how difficult it is, but we'll see if we can do it. But we'll do an open system first, where the gases produced by the chemical change are released into the atmosphere. And then we'll try to contain those gases when we later do our closed system procedure. All right, so let's get to it. So we have two flasks here. We're going to save the narrow top flask for the closed system because you have to fit a balloon over the top, and it's a little bit easier to get the balloon over the top of the narrow opening. All right, so number one, find the mass of the flask and the plastic cup and record in the table below. So here we go, we've got our balance scale here. Let's turn that on. Okay, so here's the mass of the flask. Put that on there. So write down 106.02. 106.02 for empty flask mass. Okay. Then remove the flask and get the plastic cup. And looks like we have 5.86 for the mass of the plastic cup. So write that in your table, 5.86 grams. Okay, step 2 says measure 50 milliliters of vinegar using the graduated cylinder and pour out the 50 milliliters of vinegar into the flask. All right, so here we go. So here's our graduated cylinder, and we are going to fill it to this 50 milliliter mark. Put this camera down. And here's my vinegar. And I'm going to fill it to the 50 milliliter mark. And there we go, 50 milliliter mark. Put the lid on. And I'm going to put it in the flask. So here's the vinegar going into the flask. And then we need to find the mass of the vinegar and the flask together. Here we go. And we have 155.06. 155.06. Okay, and then step 3 says place the plastic cup on the scale, push the 0 button on the scale, and add 5 grams of baking soda into the plastic cup. Yeah, I don't know if you knew this or not, but the scale has this special ability to zero out the mass. You just push the 0 button, and now I'm starting at 0, and I can measure out 5 grams of this baking soda. Okay, so here's my baking soda, and I'm just gonna put some in there until I get to 5. So up to 2.8, almost 3, 3.8. Oh, super close. Okay, I'm gonna call that good. We've got 5 4/4, 5.04, that's really close. So let's see, record the mass of the baking soda and the plastic cup together by adding the masses. So mass of baking soda was 5.04. And then plastic cup and baking soda, add the two values together. I'm going to let you do that. I'm not going to put that in the box. And then step 5 says calculate the mass of the vinegar and baking soda by subtracting the empty container masses and full masses. So you can go ahead and do that. Step 5. So mass of vinegar, you get that by subtracting. Okay. All right, and then step 6, pour the baking soda into the flask with the vinegar. All right. I'm gonna go ahead and put this on the scale, my flask with vinegar, and you will notice, it's really interesting. You'll notice as I put the baking soda in, the number will go up to account for the mass of the baking soda, but then if you watch it closely, it will actually start to drop. So you can, as you watch that, you can think about why is that mass decreasing. Let me get my funnel just so I don't spill any. And here we go. So, yep, mass went up. Now I'm going to take the funnel off and watch the mass of the scale. See, it's decreasing, still decreasing as the reaction runs. 0.22, 21, 20, 0.19, 18, still decreasing. So why would it be decreasing? 153.09 grams. Is it done? You can see gas bubbles are being produced, and as those gas bubbles rise through the liquid, the gas is released into the atmosphere where it escapes. So yeah, I don't know if you know this or not, but gas does have mass, and as this reaction is running, as gas is being produced and released into the atmosphere, it is decreasing the overall mass of the products that we started out with. Okay, so we're going to call it there. Let's call it at 153. So in your table, total mass after reaction, write down 153 grams. Okay, and for total mass before reaction, you will add up your values of mass of flask, vinegar, and baking soda. And yeah, make sure your total mass before reaction is larger than total mass after reaction. If it's not, then you didn't calculate correctly. Okay, then you answer the 2 questions underneath the open system procedure. Now let's try closed system. Closed system is a little bit more involved because we want to try to capture the gases, keep them contained so they don't escape. All right, so here we go. Closed system procedure. Find the mass of the flask and record in the table. Okay, we can do that. Gotta zero my scale out again. All right, so 100.44. Write that in your flask space. Step 2, find the mass of the balloon and record in the table. I think I'm going to end up having to cut this balloon so that it will fit over the top of the flask. So I better do my cutting before I check the mass, because I don't want to check the mass and then cut, because that'll automatically mess with my results. So let's cut it right here so it will fit over the flask better. Okay, now that I've cut it, I will check the mass. So mass of balloon, 2.24 grams. 2.24 grams. Okay, and then find the mass of the Ziploc bag and record in the data table. So here's my Ziploc bag. Now a lot of students ask, why do we need the Ziploc bag when we already have the balloon? And the Ziploc bag is just another way we can try to keep it closed and contained in case any of the gas slips through the balloon molecules. Also, sometimes the balloon just pops off, so it's good to have the Ziploc bag there. Okay, so 12.30 for Ziploc bag mass. Okay, and then we need our vinegar. So 50 milliliters of vinegar. Just straighten out. Here's my graduated cylinder. And I need 50 milliliters. There we go. 50 milliliters. Okay, now that I have my 50 milliliters, I'm going to pour that into the clean flask to find the mass and to record. That is step 4. Okay, so mass of flask and vinegar, 150.19. Okay. Then we want to place the plastic cup on the scale. Zero it out and get 5 grams of baking soda. Ooh, that one was almost 1.5. 3.5. Oh, nice. 5.02. That's really good. I'm going to keep it. Okay, so back to step 5. Mass of baking soda, yeah, fill that in. We have 5.02. You might be thinking, well, why aren't you just trying to get it at 5? Time of the video, I'm happy with 5.02. I'm not going to, it's going to be really, really difficult to get exactly 5. Okay, step 5 might be kind of tricky for me to do. Place the plastic cup on the scale and push the 0 button, 5 grams of baking soda with a scoop. Okay, we did that. And then work as a team to put the baking soda carefully into the balloon. One student holds the plastic funnel while the other pours in the baking soda. Okay, I can do that. And you can help me. So here's my balloon. I'm going to put the baking soda into the balloon using the funnel. So here's my funnel. Get this camera fixed here. Put the funnel into the balloon, just like this, and then pour the baking soda into the balloon. Try to get as much of that powder out as I can. Okay, and then give it a little shake. funnel. And there we go, baking soda in the balloon. Step 6, measure the mass of the baking soda and balloon. Oh, did I have the scale zeroed? Nope. 0, back to 0. And we have a mass of 7.25. So balloon and baking soda, 7.25 grams. Yeah, you can start seeing there are a lot of ways you can make a mistake. And if you make one little error, then it can really throw off your results. With closed system, precision is key when you're trying to have the same mass after reaction as what you started with. It's almost impossible. You have to have very precise equipment, but we're gonna try. Let's see. Step 7, calculate the mass of the vinegar and baking soda by subtracting the empty container masses and the full masses. So that's something you can do. Go ahead and do that subtraction and record your amount in the table. Okay, step 8, attach the balloon to the flask so that the baking soda does not mix with the vinegar. Place the flask with the balloon still attached into the Ziploc bag and seal the bag. All right, here we go. This is very tricky. Okay, so here's my flask and here's my balloon. Now I have to do this so no baking soda falls into the vinegar. Because I don't want to start the reaction until everything is completely closed. Okay, I'm pretty happy with that. No reaction yet, so let's put it in the Ziploc bag. So the gas that's released from this reaction is carbon dioxide. And carbon dioxide actually passes through balloon latex molecules fairly easily. So it's good to have this extra, the bag to contain any gas molecules that may escape through the latex. Okay, so I've got to be careful with the bag though. I don't want the bag to be puffy or full of air because that's just going to add mass. So I'm going to squeeze out as much of the air as I can from the bag and then seal the bag. Okay. So we've got things ready, all sealed up. So now when the reaction runs, the gas should be contained by the balloon, and any gas that might escape from the balloon can be contained by the bag. All right, so now we need to do step 9. Move the balloon so that the baking soda falls into the vinegar and starts the reaction. Let it run, and then we'll find the mass of the closed system. All right, we'll see. Hopefully the after reaction mass will be the same as before reaction. We'll see. So let me set this up. Okay, I just need to finagle the balloon. Just allow the gas up. Yeah, that's why we put it in the bag, because the balloon just popped right off. Okay, so if the balloon doesn't pop off, it actually expands and blows the balloon up a bit. Okay, looks like it's winding down, so I'm going to put this on the scale, being careful that none of the sides of the bag touch the desk or anything around the desk or even the bottom part of the scale. All right, and let's watch the scale, make sure. Okay, that's good that the mass is not decreasing. That means no gases are escaping. Okay, so it's hovering. It went up to 168.63, then it dropped down to 168.61, and now it's finally decided it wants to be at 168.62. So let's record that. 168.62 for total mass after reaction. And for mass before reaction, I'll let you calculate that. You're going to add your vinegar, baking soda, balloon, and bag masses, also the flask. So your values should be, they're not going to be identical because it's almost impossible to have identical, but they should be really close. Okay? And then answer the questions below the table and submit this to me. And if you have any questions about the results or what to do, just send me an email.